Here in this chapter, we are going to do different solid shape visualization of different 3D figures. Now, if you see here, I have a cube with me. A cube is a figure in which we have squares on all the faces. So, we have a cube here. So, it has 1, 2, 3, 4, 5, 6 faces. So, this is a cube and all the faces are identical with respect to its shape and size. They are squares. So, it has 6 faces and these are called the vertices. So, you have 4 vertices here and you have 4 vertices behind. So, a cube will have 8 vertices and these are called the edges. So, we have 1, 2, 3, 4 edges here and similarly we are going to have 4 edges behind, and so 4 plus 4 makes it 8, plus we have 9, 10, 11, 12 on the sides. So, we have 12 edges. So, every figure like cube, cuboid will have edges, it will have vertices and it will have faces, and there is a formula by which we can verify whether the number of faces, edges and vertices that we have calculated is correct or wrong. That is called the Euler's formula, where f minus e plus v equal to 2. We will be doing some questions based on that for verification. At the moment, you can understand what is the shape of a cube. Wherever we hold it, however we hold it, we find that the front view will always be a square, the top view will always be a square and the side view will also be a square. Next, we are going to look at a cuboid. Now, in a cuboid, we find that the dimensions are different, that is, the length is different than the breadth and the height. So, length is here, we have the breadth and height here, they are same. So, we have a square portion here and we have a square portion here, and the other 4 are rectangles. So, we find that there are rectangular portions all over here, but if you look at the top and bottom, they are squares. So, this is a cuboid. Now, in a cuboid also you have number of faces, edges and vertices. That is, the faces, if you look at the faces, again 1, 2 on the sides and 4 here. So, that is 4 plus 2, 6 faces. Look at the vertices, 1, 2, 3, 4 and 4, 8, and the edges similarly. If you look at the edges, we have 2 here, 2 behind, that is 4, 4 on top and 4 below, that is 12. So, this is an example of a cuboid. Next, we have a cylinder. Now, if you look at the cylinder, it is a curved surface here, there are no edges here, and if you look at the top, it is circular and the bottom is also circular. So, here we can say that this is a figure of a cylinder. Now, in a cylinder, since the faces, edges and vertices are not there, we will not be able to apply Euler's figure or Euler's formula in these type of figures. Here I have before you the shape of a cone. Now, in a cone, we find that there is a vertex here, but this surface here, the curved surface is here and we have a circular portion here. Now, this can be both open and closed. At the moment, it is closed. So, this is called the total surface area of this cone. Now, if it is open, then we say that it is the curved surface area. So, here there are no faces or edges because the surfaces are smooth, or we can say the surfaces are curved. So, here also Euler's formula cannot be verified, because Euler's formula can be verified only if the figure has got faces, edges and vertices. So, here we find the shape of a cone. So, in real life examples, we can have, let us say, an ice cream cone, we will have a joker's cap. These are all examples of cone. Next, we see a sphere. Now, what is a sphere? A sphere is like a football. It is completely covered on all the sides. It is a 3-dimensional figure. A circle is a 2-dimensional figure. So, here we have a sphere. Earth itself is sphere. All the planets, satellites, all are spherical in shape. Now, if I divide this into 2 identical portions, I divide it into 2 identical portions by cutting it by exact center, then we are going to get 2 hemispheres. So, each portion is going to be identical and this is called the hemisphere. So, one sphere can be split into 2 hemispheres. So, we can say a hemisphere can be open or it can be closed. Now, you can have a container like this which is hemispherical in shape, it does not have a cover, then we can say it has only curved surface area. But if it is covered from the top, then we will say the figure has total surface area. But when we consider a sphere, it does not have a curved surface area, it has only a total surface area, because sphere means it is completely covered from all the sides. Next figure we are going to see is the figure of a prism. Now, if you look at the figure of a prism has got two triangular portions, one triangle here and one triangle here. So, top and bottom triangles, and if you look at the figure here, you will find that it is a rectangle. So, you have a rectangle here, a rectangle here and a rectangle here. So, three rectangles and the base is triangular. So, this type of figure is called a triangular prism. Here we can find the number of faces, edges and vertices. Faces, let us see the number of faces, 1, 2, top and bottom, and then we have 3 on the sides. So, 1, 2, 3. So, 3 plus 2, we have 5 faces. Look at the vertices, 3 on top and 3 below. So, that is 6. So, 6 vertices, and let us look at the edges. So, edges we have 1, 2 and 3, 3 on the sides, 3 on top and 3 below. So, that makes it 9. So, Euler's formula can be verified for a prism. Next we have a pyramid. Now, this is a pyramid and this has got a base, triangular base, and we have got 3 triangles on top. So, this type of pyramid where the base is a triangle is called a triangular pyramid. So, here in a pyramid you will find again there are 1, 2, 3, 4 faces, and then we have 1, 2, 3 edges here, and we have 3 edges below. So, total of 6 edges, and we have 1, 2, 3 vertex here and 1 vertex on top. So, 4 vertices. So, Euler's formula can be verified for this figure as well, and this is a pyramid and it is called a triangular pyramid because the base of this pyramid is triangular in shape. The base could also be a square, which I can show just now with the help of another pyramid here. Here we have a square pyramid. The portions on top are triangular. So, we have 1, 2, 3, 4 triangles on top, but the base is a square. So, when the base is a square, we call this as square pyramid, and here also we can easily find out the number of faces, edges and vertices.